So greetings. We are on day two of ResPack conference at the Lalit Hotel, and we have with us Dr. Vijay Habbu, who is the adjunct professor at ICT, former vice president at Reliance, and also technical advisor for PACE. So thank you so much for doing this. This is the day two of ResPack, and lots of conversations about polymers, plastics, biopolymers, recycling. We have heard. But again, coming to the theme of the conference, which is responsible packaging, what does responsible packaging mean to you, and how is it important?
Packaging is important, that I think everybody by now understands. We ourselves are a package.
Yeah.
When we were born in what is called an amniotic sac, which itself was a packaging. So packaging is essential right from our birth to our death in all aspects. But what is responsible packaging is, in my opinion, a simple definition is which doesn't cause any burden on the environment while being prepared, during its use, and after its useful life. So to me, while the first two parts are phases of packaging life are generally discussed, that what happens, what is the carbon footprint during its manufacture, what is the carbon footprint or other things or eco footprint during its use. What is not talked about, which in my opinion misses the most important point of responsible packaging, is the end of life fate.
Okay.
What happens to the packaging after its usefulness for the purpose for which it was made? It gets over. How does it get treated? How does it get disposed?
Yeah.
What is the fate of it? So end of life fate, if it is meaningfully designed, then that is responsible packaging, in my opinion.
Okay, and yesterday you hosted a wonderful panel discussion with the brand people. So it was, of course, of the beverage brands and all. So what were the viewpoints between what the consumers demand and what the brands can actually offer or deliver? So
in terms of packaging,
yes.
from consumers' point of view, packaging should be something that they can easily handle. It's friendly to handle. Also functionally, it allows them to preserve the contents until as long as they want. For example, even in sips. Suppose if I have a water bottle in PET, I can drink sips of it as and when needed, and the remaining part of it I can keep in my back pocket and carry it along until I finish it off.
Yeah.
Would that shape, size and lightness be available in any other format or in any other packaging material? Suppose if there is a kind of brick shaped material, of the packaging, will I be able to carry it? Suppose if I've taken a sip of it, but I don't want to throw it.
Yeah.
And I want to carry it along until the next, whatever time I have spending in, for example, in an exhibition or in a garden or in a zoo. Will I be able to put that brick with remaining water in my pocket easily, as easy as in PET bottle? So these are the kind of convenience also one consumer probably would look. And of course the price.
Yeah.
And for those who are very kind of aware citizens and responsibles, they will worry about what happens to it after the life, whether it's recycled or not. But that kind of awareness in common consumers is not there.
Yeah.
So to me, cost is the foremost thing, the convenience and the kind of convenience both during for handling and convenience for carrying. These, in my opinion, are what the consumers look for.
Yes. And since you touched upon the aspect of bottles, PET recycling has a very strong footprint in India. So what are the hurdles that the beverage brands are facing, in order to achieve a complete bottle-to-bottle circularity?
Actually, PET recycling is not only high in India.
Yeah.
By virtue of its chemistry and the format, it's the highest amongst each countries. It's the highest recycled plastic.
Okay.
And so is it in India. In India, it is even higher because the utilization of used PET bottles for converting into textile fibers and then into garments has been a long, quite an industry. Several decades before the conversation on the sustainability started happening.
Yeah.
And then the obvious next step was to, that was called bottle to fiber recycling, B2F. But now, so it was just one step away from bottle to bottle recycling. So that is the advantage which PET has by virtue of its unique chemistry and its unique format. Format meaning what? It's a rigid plastic, which means it's easy to collect. So therefore it comes into the recycling chain very easily. The challenges is that left to itself, it was doing a good job of recycling, whether it getting converted into fiber or bottle, whatever the natural course for businesses. What is a natural course for business? Of course, it's the profitability.
Yeah.
So where profit goes, that's a natural inclination. But added to that came an enforcement through regulatory force. That means you have to recycle it.
Yes.
Whatever PET you use, you have to not only recycle it, use X percentage of the recycled content into your next packaging. So these are the regulatory pressures. They are not all unwarranted, but some of the requirements placed are unrealistic. That means to expect 30% recycled content to go into my new PET bottle.
Yeah.
When the recycling capacity itself is not that fully up to that level. It is getting there, but it's still not there. Not to 30%, you know, a little, so 20% would have been a good start.
Yes.
Or 15%. So a realistic start that would encourage the industry to go more for it, build confidence and go up. That would have been a good stage-wise introduction of that requirement. So that's one hurdle which they will face.
And again, we have the contrasting viewpoints of the beverage brands is that while creating premium packaging for consumers, there's this design for recyclability guidelines as well. So how are they balancing that? And
true, but that funnily that happens only for plastics. So for example, similar requirements are not placed for glass and probably for other, like in Europe they have plastic packaging waste regulation, PPWR, that is there. So to that extensive level, we are probably in India are not reached there. But of course, again, what I'm saying is the use of used glasses, glass bottles is there because intrinsically it is driving that way. But what gets hidden in these reused materials for, let's say, glass bottle is the tremendous amount of water, energy and cleaning chemicals that are required. So that generally doesn't get dialed into your conversations of about what you achieve or what you are supposed to achieve by reuse for environmental reasons. Ignores the fact of the eco footprints that comes through the use of water, steam, cleaning chemicals, drying, those kinds of things. So these are some of the challenges that probably done. So I think they should be left to themselves. They will do it anyway if it makes economic sense to that thing. But a similar requirement on packaging, for example, is not placed on the reuse of it for other kind of formats. So it's probably an unfair treatment to plastics.
Yeah, and I would like to, we spoke, I think, couple of years ago about biodegradability and bioplastics. So right now, what we are hearing from the industry is that the usage or the growth of biopolymers and bioplastics is the quality that bioplastics or biopolymers provide are not equivalent to that of the virgin materials or virgin plastics. So what is the growth that is happening, or are the biopolymers reaching there? Because yesterday I spoke to someone from Nature Tech, Mr. Sundar Balakrishnan. So he was quite optimistic about it. So what are your views on bioplastics and biopolymers?
So I am now going to respond to it purely as an academician who teaches polymer science.
Yes.
So firstly, you used the word bioplastics and you contrasted it with virgin plastics. So that's a wrong, probably you slipped that thing. So bioplastics versus synthetic plastics.
Yeah, of course.
Because virgin plastics, it has to be contrasted with recycled plastics. So that contrast is there, but virgin plastics has got, because you can have virgin plastics in bioplastics, you can have virgin plastics in synthetic plastics also.
Okay,
so the distinction is really in classes. The classes are really bioplastics versus synthetic plastics. Synthetic plastics being the first ones that emerge on the scene. Now, just the word synthetic should not be a cause of concern. So many things are synthetic. Your medicines are synthetic.
Yeah.
Today's allopathic medicines are all synthetic. Does that make it harmful? Glass is not natural. Glass doesn't grow on trees.
Yeah.
Glass is made from natural raw materials, but it has to be synthesized into the form that or cutlery, crockery, these are all made from raw materials, but the material is synthetic material in the end. Paper is not a natural material. Paper is made from natural raw materials, but it has to be synthesized.
Yes.
There is no paper grown on trees. Paper is made from trees. So similarly, plastics are made from raw materials which are in nature. I mean, fossil fuel, they reside in nature. So we need to be very careful with our conversations, what we may call that thing, but we need to understand that before we assign any kind of qualitative goodness or badness to it, we should be aware of the fact that most of the materials other than cotton is all synthetic. Paper is synthetic. Paper is synthesized from raw materials. Glass is synthesized from raw materials. Plastics are synthesized from raw materials. In some cases, raw materials, what is synthetic chemical? Something that you first take out crude oil. Where is crude oil residing? In the natural environment. Okay, that natural environment is not on the land. But sea is also a natural environment. So plastics are also that way. But assuming that what is being said is that, to contrast it with bioplastics, is some of these plastics are made on land, or the raw material is grown on land. So that qualifies them to be called as bioplastics. Now the word bioplastic itself needs to be understood. The word bio needs to be understood properly. Bio means, for all the common understanding, is that something that originates, as we just saw, on land.
Yes.
So the raw material could be extracted from land, from plants or whatever it is. But the raw materials are then have to be cooked up into a reactor and synthesized into a polymer. And that polymer will subsequently have to undergo the same plastic shape formation processes that other plastics are going to. So any biopolymer is also a plastic if converted into the plastic articles that we see. A bottle made from PET is as much a plastic as a bottle made from PLA. Both bottles are plastics because they undergo the same extrusion, injection molding, blow molding processes. So the shape forming process, so they are as much plastics. What probably differentiates is even the polymer, final polymer, if it's extracted from nature, such as cellulose, such as chitin, chitosan. These are the polymers which nature makes in the polymer form itself. Whereas PL and or PET, their raw materials are made or extracted from nature. In the case of PLA, the raw material monomer itself is made from the first stage of the monomer. That lactic acid, first it has to be fermented to get lactic acid. So as such, that monomer is not available. So you have to do conversion processes, get first intermediate, then that lactic acid has to be converted into a lactide, and then it has to be polymerized. And then the polymer has to be extruded using the same plastic processes as needed for any other synthetic plastic. So just because my raw material starts or is made from raw material doesn't confer on me an automatic heavenly attribute. What determines is if the final plastic is how easily it decomposes and how it decomposes. While decomposing, what does it give off? And so in the case of, let's take the example of synthetic plastics such as PET, because that's the common material found everywhere, and that's a kind of become a representative of everything about plastics, good or bad. Now PET, as we just said, has been long being converted into fibers, and now recently, because of the regulatory push, into bottles. While doing that, is any harm caused? No, unless you are caught up in the verbal duel of whether it is recycling or downcycling, how does it matter? It is getting converted into a useful article, which has a long life. Even in bottle to fiber, the textile fibers, one doesn't discard the fibers for 20, 30, 50 years, so it remains in the system for decades. The jacket that I'm wearing is also made from recycled PET bottles, and even I'm looking smart in that.
For sure.
So yes, it is not bottle to bottle, but in the case of bottle to bottle, yes, so it will be again meet the fate and it will go in that cycle.
Yeah.
In contrast, if you have somebody claiming that this is a biocompostable material or biodegradable materials, which incidentally are two different things.
Yeah.
Biodegradable material which will undergo degradation under the action of bacteria and everything. Bio means anything that is living form, whether plant, animals or whatever it is. So undergo that thing under certain conditions. And there you can have aerobic or anaerobic, that means whether you have oxygen with it or not, oxygen assisted or in the absence of oxygen. Now in the case of biocompostable, also that biocompostable plastics are not compostable in home composting machines. They have to be sent to industrial composting machines. Why? Because for achieving that kind of composting, that means the degradation under the action of certain bacteria, under the action, under controlled condition of temperature and relative humidity, those can be achieved only in industrial composting facilities. Now what happens is, because in that anaerobic condition, so water plastics, particularly synthetic plastics, or even the raw materials, that even in bioplastics and all, they are basically chains of carbon and hydrogen. So that means they are hydrocarbons.
Yeah.
If there is an oxygen built into the chain, it is a carbohydrate, but essentially they are hydrocarbons. So when you decompose them, water will get formed necessarily, and if there is less of oxygen, then carbon monoxide will get formed. So what, during the process of degradation in an industrial composting machine, you are going to release carbon monoxide and hydrogen. Carbon monoxide is a greenhouse gas.
Yeah.
So you are converting land pollution into air pollution.
Yes.
So that's the only thing. So pollution is not taken, it goes away from your site.
Yeah.
But there is again a catch. A bioplastic or biocompostable material will be put into, let's say, and for which currently in India there is no industrial composting facility. So eventually this is going to go to a landfill. But let's assume the real scenario. It will be sent, suppose if tomorrow 500 industrial composting facilities come up in the whole of India. Let's assume that. But those bottles, biocompostable bottles, will have to be sent to the industrial composting, which means they will have to be picked up.
Yes.
The picking or collection mechanism is the same for the current plastics or other waste, street waste. So if a rag picker or waste picker will pick up biocompostable bottles, why will he not pick up PET bottles?
Yeah, of course.
So for him, it doesn't make a difference. So, but if he was able to pick up PET bottles, then why is the remaining 10% on the litter, which is making such big noise about? So, the rag picker is not going to preferentially pick up the biocompostable material because it is made from a natural raw material. So, this is a fallacy that is being propagated, that so there are these intrinsic hurdles, that means the pickability, there is no preferential pickability, collectability. Then during the course of industrial composting, assuming that such facilities are there, the end product is going to be carbon monoxide, which is a greenhouse gas.
Yes.
In the case of biodegradable plastics, because it's aerobic degradation, it is going to give a carbon dioxide and water. Carbon dioxide is also a greenhouse gas.
Yeah.
So all these mechanisms of dealing with these plastics after their life will generate some kind of thing. Contrast this with the emissions during mechanical recycling of PET. Nothing is happening. Water is consumed for washing and everything. So there is going to be a water load on that thing. Compare it with the emission load of this thing, which is more harmful to it. Or let us at least agree that both have some degrees of problem. So one is not coming out as a solution to the other. It's just a new polymer, which should be treated as such. All materials will have some deficiencies. But the deficiencies are fewer in the case of synthetic materials or synthetic plastics, because over a period of time, over decades, people have stabilized the end applications for each polymer. that kind of stability, for example, PET has fantastic, say, oxygen barrier properties, but it doesn't have hydrolytic stability. Polypropylenes, on the other hand, very poor oxygen stability. So, does it mean that one is bad and the other? No, you say, do what is called fitness for purpose. So, I need these properties, so I pick up this. I need this properties, I pick up that plastic. It's the similar case for metals. One would ask whether is aluminum good or bad. If you look at it one angle, aluminum is highly toxic. Do we stop using from it? You have aluminum tawa made from it. Aircrafts are made from aluminum, not iron. So there is a reason for that thing. Is iron good or bad? If I say iron is good because I can make a hammer out of it, but iron rusts. So depending on what application, so every material will have a fitness for purpose. Then go the accompanying properties, cost. For consumers, it's the biggest thing. So plastics are by far the cost-effective materials. No material is perfect, so there will be some deficiencies here, some deficiencies there. If people start looking for a perfect material, they will not find it. So we have to make do with whichever has the fewest problems.
There's no one material fits for all.
That's right. I mean, glass is a beautiful material for chandeliers. Plastics can never take that sheen and everything.
Of course.
But for water bottles on the go, PET is the best material. So there should not be any quarrel in that kind of thing. Glass is a fantastic material for packing other beverages and other things. No issue on that thing.
Yes. And one of the things which you had told me long time ago was that the claims of biodegradability is not a magic wand.
Thank you for reminding me. So then the claims I have recently heard people talking about biocompostable. No, theek hai. So they now acknowledge that there are no industrial composting facilities. So what do they now do with the material? They say no, it is highly degradable. Highly means what? So if I litter let's say a biocompostable material on the streets, will it automatically swoosh off in the air? It doesn't happen that way. So it degrades faster. How fast? Let's say 1 year, 2 years. So which means the same litter on the streets will have to be there as an eyesore for me for a year until it degrades naturally. So these are, in my opinion, these are the things which give bad name, because then these are considered as greenwashing. And even genuine efforts for recycling and everything get a bad name because of such false claim. Biocompostable plastics are good materials as a novel materials. But the novelty should be gainfully deployed by finding appropriate applications.
Of course. And moving back to again PET bottles and recycled PET. So how do we encourage the usage of rPET in the bottle packaging industry or beverage brands? How do we encourage these brands to have more content of rPET or?
No, why there is no need for encouragement anything beyond what the regulations have already placed. Regulations have mandated some of these percentages. So if the percentages are kind of gradually year-wise they are going to increase, so that is automatically going to be a pressure on beverage manufacturer to incorporate that much of thing. But we have to see this with a caution. So not only the availability of rPET, but we have to understand that after all this is an organic molecule, PET, or all plastics are organic molecules. So with every thermal cycle, they will create some new issues. Discoloration is one issue. Loss of molecular weight will be an issue. So all these things will have to be managed, and in fact, going to higher amounts of recycled content will pose these extra challenges. And there are several more layers of problems that may emerge, for which we need to be ready with it. So blind force or nudges to go on increasing more and more and more and more recycled content, in my opinion, is not a scientifically approachable these things. So we need to treat this with caution. One good way of encouraging rPET use of at the same time recycling enforcement is also a good thing. In my opinion, the best way to do this is force this recycled material for packing solid substances. Like chocolates, candies, or even your earbuds packing, or for other materials such as you want to pack Dettol or any such thing which are not consumed. So those are the areas where you should kind of push.
Since you spoke about the small format packaging, the small sachets and stuff, we 2 or 3 months ago, Ellen MacArthur Foundation published a report on using paper-based flexible alternatives instead of plastics, or replacing plastics with paper-based flexible packaging for small format packaging. So do you think the industry is embracing that thing, or how is it?
I mean, as I said earlier, everything boils down to cost and what are the contents. If there are solid contents, for example, these days people are using plastic for packing all sorts of things, including in haldi kumkum also they are now these days packing in the small pouches. So depending on what contents are being talked about, small sachets, for example, if you want to pack, let's say, body soap, you know, the mouth fresheners, by all means go ahead, and it's a fitness for purpose.
Yes.
It also depends on the shelf life that you are expecting, that kind of thing. Paper, when we are saying paper on its own, but sometimes what happens is you want to show that outside is paper, but you have to, for ensuring barrier properties, then you coat it with something else.
Yes.
That something else can be again plastics, or newer things like silica and alumina, and all those coatings are also going to be there.
Yeah.
That's going to increase the cost. So if it is affordable, cost effective, by all means do it. There is no issue on that thing. But the moment you have alumina and silica coating on that thing, what happens to the recyclability, or what happens to the natural decomposition features needs to be investigated. But as such, there is no harm if somebody is kind of for the purpose of a new product, because so the packaging is proliferating to unimaginable things. So things like we never imagined. Haldi kunku was a shock to me. In one of the weddings, they were packing these small haldi and kunku, this thing, in plastic. So if those are the areas where, you know, paper packaging can go, it will certainly no need to use plastics for all these kinds of things. So paper is an eminently, so that's what I'm saying. For all materials, best thing to do it is, without getting into these intermaterial wars, find the correct applications where customers will find paying that much money for the purpose appropriate. That's a natural fit.
Of course, yeah, and that has to be studied.
Yes.
And what about EPR? Do you feel the brand owners are taking?
Yes, as I said, you know, EPR, I mean, everybody is indeed taking, and which is where the concern comes about. The requirement of EPR is extended producer responsibility. So it is not one thing. Within that EPR, there are 3-4 obligations. One obligation is to do all of your pack, and this again happens only on plastic. I mean, other other packaging materials, nobody kind of is talking about it as much as passionately as animatedly people talk about plastic packaging. Okay, let's be that as it may. Even for plastic packaging, one of the obligations of under EPR is that I will recycle 100%. So that obligation deadline was in 2024. I think no earlier than that. The second obligation was to incorporate X percentage of it into my packaging.
Yes.
And that has a graded approach. By 2028, the plastics are expected to reach 60% incorporation of recycled plastics.
Okay, wow. Hey.
For grade category 1 plastics, for other plastics there is a lower amount. But for each category of plastics, there are kind of increasing requirements of recycled content. The third obligation is reuse. That obligation is placed only on category 1, that is rigid plastics, that too on PET material. So it's a material that is intrinsically very naturally getting highly recycled. There is an obligation on reuse. In my opinion, one of the most irrational applications. How do you suppose there is a 2-liter water bottle? How do I reuse it? So which means an empty bottle, which is lightweight, much lightweight than see, there is a difference between reuse, placing a requirement on heavy materials such as glass versus a light material like plastic. So if you want to carry that plastic to my reuse bottling, original bottling plant, which means my truck or tempo, which has a 10-tonner capacity, because of the volume of the bottle, it will be carrying only 500 kilograms of the material. So my logistics cost will go down.
Yeah, of course.
The other thing is what happens in some bottles there will be lids, some bottles there won't be lids. Then I have to take it to the bottling plant, wash them under industrial washing conditions, which incorporates water, steam, industrial chemicals, then drying. What happens to the eco footprint there? During the process, that bottle may get nicked, compressed, so I have to blow it back to its original shape. I have to fix this thing, I have to relabel it. The original label may not fully go off. The consumer can easily recognize this is a reused bottle. Will he buy it? But what happens to the cost? The logistics cost. So environmental print. So technically and environmentally, I don't see any sense in that thing. And in larger bottles, they were getting reused anyway. As I said, all the big brands, their 20-liter jars and all, they themselves are picking it up and going it out. That is what I'm saying. Many times, money or business itself drives the activities that are considered sustainable. There is no need to bring in extra regulations and actually make life difficult and be seen as a laughing stock. To expect smaller bottles than 20 liters to be sent back mandatorily for reuse, in my opinion, is a laughable requirement.
And of course, we have been having a wonderful chat so far. And I know you have a lot to share, but before we let you go, one final thought we have is that what you gave based on the panel discussion that happened yesterday. So what a quick encapsulation of what was the major key takeaway that you think the audience took from the panel?
The audience took from the panel, in my assessment, was that, it's brand owners are also doing a lot to strike a balance between what are sustainable goals. At the same time, the very same customers who are wanting sustainable materials, their willingness to pay the price. So cost is an important thing which they have to worry. And the format of the material and how the transportation ease and everything. So these are the materials the brand owners are putting in immense efforts. In one case, I also heard that two brand owners came together to standardize the SKU, which in many ways is a fantastic step which I have been advocating for long, that if packaging gets standardized, for example, slightly straying away from yesterday's this thing, if for example cookies, all biscuit brands come together and they standardize a kind of packaging format for all their cookies, irrespective of their size and shape. Cookies would be generally, essentially would be having the same properties in terms of shelf life. If they standardize the same MLP structure, then handling that much, so that will reduce the kind of variations that today exist in the MLPs used by different brands to pack their biscuits. So if you can reduce the complexity by coming together of industries which otherwise are competing, let the competition be there for their taste, flavor, size, shape, attraction, that's fine. But for packaging, if they come together and reduce the complexity of the material that goes out into the litter or for the recycling chain, that will be a good thing, which I also heard two competitors speak that thing. The one other thing is that a lot of awareness is happening between in brand owners, the need to collaborate between academic institutes and everything to develop better material. I think that was it.
Yeah, that's a fabulous takeaway, I think. If they are competing for the product, then why not come together for packaging, create a common packaging?
I mean, common material for packaging. You can still maintain the shape, size, whatever, marketing requirements are there in terms of that they can do. But at least in terms of complexity of the packaging reducing, that will be a good step.
All right, that's a great thought to end this conversation on, even if I don't want to end this. So hopefully we have a lengthier chat somewhere outside during the lunch hours. Thank you so much for doing this. You have been...
Thank you very much.
You have been training me since I was a teenager. But so one last thing we have to give you is the This is the new look of the What Packaging magazine. It is rebranded, refurbished, and repackaged. Here we are launching it at the ResPack conference. So this is for you to keep.
Thank you. Thank you very much.
Thank you so
Thank you.
much.